Okay, now for the second part, which is the balancing bit. Okay, so basically the balancing idea is to make sure that you have the same number and types of atoms on this side as you have on this side. Okay, so we're going to be doing some vocabulary as we go, and I'll be giving you some tips and tricks for how to make things work. Okay, first things first. The Everything on the left side of the yields arrow. Okay, so let's go ahead and do our vocabulary. This right here is called the yields arrow, and it can be read as yields or produces or whatever. Everything to the left-hand side of that are the reactants. Those are the things that are reacting together. Everything to the right-hand side of that are called the products. Now, in earlier guided notes, we talked about the difference between subscripts, which are the numbers down below, and coefficients, which are the numbers in front of the equations or the element symbols. All right, and so we're not going to go over that again, but we have gone over that in the past. All right, little trick that I find it helps, especially in the beginning. If you will just draw a box around the compounds. Now, the rules are you cannot change anything inside the box. That's hands off. You don't have any access to that. You don't get to decide that silver nitrate is not AgNO3. You don't get to decide that copper nitrate is not CuNO3 too. All right? So hands off everything there. Now we're simply going to count the atoms on both sides. So copper, there's one of them. Silver, there's one of them. Now this time I'm not going to count nitrogen and oxygen separately. And the reason I'm not going to do that is that those are both polyatomic ions and they are the same on both sides. They do not change. So I'm going to take a little shortcut and I'm going to just do NO3. And NO3, there is only one of them on this side. Now on the other side, copper, there's one. Silver, there's one. And NO3, there are two of them. All right, so now the rules become you change the coefficients to make things match up, right? So there's two nitrates on the right-hand side. There's only one on the reactants or left-hand side, so I have to put a 2 right there. Now I want to give myself a little space so that I can erase. So I'm going to put a 2 right there. But then that means you got to recount everything in here. So that 2 goes with that silver. So now there are 2 silvers. The 2 also goes with the nitrates, 2 nitrate. So now what's unbalanced is the silver. There's 2 on the reactant side, only 1 on the product side. So now I need to put a 2 in front of that silver. That becomes a 2. Everything is balanced, good to go. Next, just like before, we're going to box the compound. You cannot do anything inside that, change anything inside that box. Then we're going to count them up. So hydrogen on the left-hand side, there's 2. Oxygen, there's 1. Hydrogen, there's 2. Oxygen, there's 2. So clearly, I've got to make that into 2. I'm going to do that by putting a 2 coefficient in front. But that goes with everything, right? So this 2 times that 2 is going to give me 4 hydrogens. 2 times 1, 2 oxygens. Now I've got 4 hydrogens on one side, 2 on the other. So I'm going to have to put a 2 there. That brings me to 4. And now I'm balanced. Okay, next. Remember, you can't mess with anything inside a box. The formula of the compound is the formula of the compound no matter what. All right, so here we go. Sodium, I've got 1. Chlorine, I've got 1. Iron, I've got 1. Now, take a look at this though. That is a hydroxide ion. And there is another hydroxide ion right there. That is a polyatomic ion. It does not change. And so I'm going to treat it as an OH, not as a separate oxygen and hydrogen. You can do that if you want, but it's easier to treat it as a polyatomic ion. So OH, I have 2 of them. On the other side, I got a sodium. I've got an OH. There's only 1 of them. I've got a chlorine. There's 2 of them. I've got an iron. There's 1. So you can choose the chlorine if you want to focus on, or you can choose the hydroxide to focus on. Either one's fine. So if I choose the chlorine, I've got 2 here and 1 here. So that means I'm going to need to put a 2 here. Then I'm going to need to recount. Sodium becomes 2, chlorine becomes 2. Well, now I've put my sodiums out of whack. So I've got to put a 2 there. Now that makes my sodiums 2 and also my hydroxides 2. And magically, I've now balanced everything, even though I never really looked at the iron. Combustions can be difficult, okay? There are some tricks, but they don't make any sense really to go into before you try a couple yourself. So, first things first. Let's make sure that we don't mess with any of our compounds. C2H6, it's called ethane, carbon dioxide, water. All right, now, carbon, I've got 2, hydrogen, I've got 6, oxygen, I've got 2. On the other side, carbon, I've got 1, hydrogen, I've got 2, and oxygen, I've got 2 for the carbon dioxide plus 1 for the water, that's 3. Now, the main trick with combustions is you don't worry about oxygen to the last, okay? Oxygen, you always save it for last. The other trick is usually to start with carbon. All right, so those are your 2 tricks for doing combustions. Okay, so I've got 2 here, 1 here, so clearly I'm going to put a 2 right there. That makes me recount my carbon. It also makes me recount my oxygens, but I've got to be careful though, because 2 times 2, that made that one into 4. It did not change that one. So now I've simply gone to 5. Next, I'm going to look at my hydrogens. I've got 6 on one side, I've got 2 on the other, so clearly I'm going to have to put a 3 right there. So that's going to cause me to recount that. That's 6, right? Then now 3 times 1 is 3, so I've got now 7 oxygens. Okay, now here's the problem. This is 7, this is 2. There is nothing that I can do to cause 2 to be 7. I can't multiply 2 by any whole number that makes it into 7. So I can do one of 2 things. I can do what we do in the rest of chemistry, and I can put a 7 halves in front of that. In other words, 7 halves or 3.5 oxygen molecules will make that equal. All right? Now the reason that that works is that you have your 7 halves, you're multiplying it by your 2 oxygen atoms, the 2's cancel, and you have 7. All right? If you don't like that, then the moment you realize that that is going to be an odd number, then you multiply everything by 2. All right, now, what would that do for you? Well, let me grab this thing, and I'll show you what it'll do for you. Okay, if you do that, you multiply everything by 2 right in the very, very beginning. So you go 2 C2H6, 2 O2, 2 CO2, 2 H2O. Then when you do your counting, you're going to get 4, you're going to get 12, you're going to get 4. Then on the other side, you're going to get 2, you're going to get 4, and you're going to get 2 times 2 is 4, plus 2 is 6. Then we'll do our balancing just like we did before. We're going to have to double this, so that's going to become a 4. So now we've got 4 carbons, 8 hydrogens. Yeah? And so now we're good there. Now on this side, oh, excuse me, did I say, I didn't mean to do hydrogens. We've got 8 oxygens here, we've got 2 oxygens here, so that brings us to a total of 10. All right, now here we've got 4 hydrogens, 12 hydrogens. We got to multiply this by 3, so that brings it to 6. So that brings that to 12, and then that's also going to change our oxygens. 4 times 2 is 8. 6 times 1 is 6. That's going to give me 14. Now I have an even number of oxygens, so in order to get those to equal, I multiply O2 by 7. And everything balances out. All right? So you can do either one. You can do the multiply by 2, or you can do the 7 halves. Either one's perfectly fine. All right, only 2 remaining. Can't change the compounds. Can't change the compounds. Can't change the compounds. Can't change the compounds. All right, now, little trick. We know from before, this is an acid-base reaction. That is a hydroxide, right? Well, we can think of water as hydrogen hydroxide if we want to. It's the same thing, HOH. That will allow me to do my little polyatomic ion trick. So, hydrogen is 1, chlorine is 1, sodium is 1, hydroxide is 1. Hydrogen in this case is just that one, okay? So that's 1. Chlorine is 1. Sodium is 1. And hydroxide is 1. Well, look at that. It's already balanced. Don't need to worry about it. Final one. Can't change the compound. Can't change the compound. All right. Magnesium, 1, oxygen, 2, magnesium, 1, oxygen, 1. So clearly, I've got to multiply the 1 on the right by 2. So I'm going to do that. That changes that to 2. That changes that to 2. So clearly, I now have to multiply the 1 on the left by 2. And that balances everything. All right, guys. So you'll be doing the practice types of reactions. There's an answer checker for the first 5, and then the last 5 are Canvas quiz.